So just like the explicit formula in arithmetic, the explicit formula jumps you straight to any particular term. So if you plug 5 in, then it should give you the value for the 5th term. Remember, n is still counting up the term number. N equals 1, 2, 3, first, second, and third, and fourth, so on. Big difference is geometric sequences require an exponential equation. So the n is going to be an exponent. A sub 1 or G sub 1, your starting value, is still necessary, as is the constant ratio. Don't forget, that's what we're multiplying by each time. So this is what it would look like. A sub n equals a sub 1 times r to the, and this is counterintuitive, but to the n minus 1. Here's why. We know that for n and a sub n is the term number, right? So I know that if I plug 1 in for the term, I should get whatever the value of a sub 1 is, right? So if I actually do this with this equation, if I actually do a sub 1, it would equal a sub 1 times r to the 1 minus 1. So what I've done is I've actually plugged the value for n in. What is 1 minus 1? Why, it's 0. So I have a sub 1 times r to the 0th power. What is anything to the 0th power? 1. So this is just a sub 1, which is what we hope for. Right? Yay! But that is the big thing to remember, is we have to have that n minus 1 as part of the explicit formula for the geometric sequence. So for example, if I'm looking at this, what I'd probably first do is take 6 and divide it by 2 and get 3. Then just to make sure, I'd take 18 divided by 6 and get 3. What does this mean? R is equal to 3. Then, with a lot of head scratching, I'd figure out that a sub 1 is equal to 2. This leads then, well, it's actually pretty straightforward, to an exponential equation. A sub n, this is what your book is going to do, so we might as well do that, is going to equal a sub 1, or in this case 2, times 3 to the n minus 1. Now please note, just like any exponential equation, I could write this as 2 times 3 to the n minus 1. That's usually not a bad idea, because sometimes that dot becomes a minus accidentally and silly things happen. But please bear in mind, we're just raising the 3 to the n minus 1 power. And that, in one step, would give you the value for any term n in a geometric sequence.